I'm Peter Davies. I'm the CTO of Boom Running. We're experts in the world of high-speed energy monitoring and management systems, data analytics and artificial intelligence. He's given a presentation on the benefits of second-by-second monitoring and faster in regards to half-hourly data and slower. So I'm just going to give a bit of a presentation on the quick overview of energy monitoring, the differences between second-by-second faster and slower rate systems, run through a case study to demonstrate this, talk about behavioural change and display benefits of getting this high-speed data, talk about the NILM technology, so that's Non-Intrusive Load Monitoring, and then go into the development of where I feel the future of energy monitoring and management is going. Okay, so Adam obviously ran through a lot of this. So quick thing on meters. You've got three different types. You've got your kind of smart meters up to the left. You've got your BMS type meters below, and then you've got your retrofittable meters, which are where you kind of put your current clamps and voltage clips on. All these obviously nowadays pump up to the cloud, and you can analyze it remotely from wherever you are. So what are we actually measuring? So every individual appliance has a power signature. So at any particular time, you can see here, there's a power signature for 3 domestic appliances to kind of make it a bit clear for you. So at any particular moment in time, so I'm struggling with this clicker, it may look like a noisy signal that you're getting a data point from, but actually all it is a broken down signal from those individual appliances which are on at the same time. So every appliance actually has effect on the meter itself or on the reading. So if we look at typical half-hourly data, so this is a kind of benchmark data standard from the kind of half-hourly meters and AMRs and smart meters. And the cool thing is it's really good for spotting trends that's been discussed. This company came to us because they were having a power cut and wanted to work out. And you can see, so commercial building, 3-phase system. You've got, obviously phases 2 and 3 look like the higher values. They'd probably be the first place that you would go to if you were trying to work out where the problem was happening. But the joy of monitoring in second-by-second level is you just get far more clarity in terms of the data to actually be able to sit and work this out. So within a quick split second of looking at it, you can see that actually the power cut is caused by the third phase, the white one. But you also get extra information. So you can see at night time this kind of load pattern here is, you're talking outside load. You can actually see there's just one individual appliance which is turned on and caused that. But if we zoom in on this particular hour that we're worried about for the power cut, in second-by-second resolution, you can see quite clearly there's just one very large appliance which is on that phase. It's the equivalent of about 5 kettles that's appliance. And so that's going on during this kind of small window during the middle part of the day. And the reason the power cut is happening is there's another appliance which is also turned on at the same point, hence it's tripped their breaker. So very quickly we can see that actually if they just put that very large appliance and split it across all 3 phases, they'd solve their power cut problems in a second. So let's look at that exact same data set on a half-hourly data meter, try and analyse it using that data. You can see again quite clearly the difference in resolution to be able to actually analyse these problems. So you know you've got a problem, second by second you can actually solve it. But I hear a lot of bad press about this kind of high resolution data, and a lot of that kind of comes from 15-second or 1-minute data. So if we look at this exact same time period again on a 1-minute data feed, you can see that there's a bit more information. It's certainly a lot prettier. You can kind of see a very nice church on the kind of right-hand side and maybe a small mounting range on the left-hand side. There's no actual appliance information or anything there to be able to solve it. You just might actually look at that phase to solve your problem as well. So that's where I think a lot of kind of high-speed monitoring gets its bad press. It's not as fast as second-by-second or faster. So just to kind of recap, half-hourly data is great for kind of trending and getting you kind of an overview for what's happening in your system. Greater than kind of second-by-second range is slightly more prettier, but actually doesn't really give you any more information. But second-by-second, you can actually delve down and get the details to what is actually causing your problems, or show you where you can actually make your savings. So just to give you another quick example, this is a typical office building that had 9 to 5 standard usage. They approached us because they had very high energy bills. So you can see quite clearly here that it's completely opposite to what we would expect. You would expect it kind of low during the evening and night and high during the day, but it's completely opposite. The benefit of second by second is we can zoom in on that data. So if we zoom in on the kind of point where it actually starts to drop, so 9 o'clock when everyone kind of turns in, you can see that actually it's just one huge appliance which seems to be turning off at 7:53 AM in 12 seconds, which is causing this entire data flow. So we basically rung up the company and asked them what happens at 7:53 in 10 seconds. And they explained that that was when all the lighting was turning on in their office building. So it's like, okay, lighting, what type of lighting is it? It was incandescent fluorescent. So it's like, okay, well, that sounds like it could be playing with your power factor. Do you have anything that could be working on your power factor? And it turned out that the building that they were using and converted into offices actually used to be an old machining plant. So in the building itself was a power factor correction unit, which just nobody had been paying any attention to or worrying. So within about an hour, they turned that system off, and you can see the next day's profile back to a kind of normal, what you would expect office building. And you can then go into the detail of solving the other items, which obviously stand out for the evening. So within 24 hours, we'd save this company over 50% on their reactive power usage, just by the benefit of having second-by-second monitoring. Know that we were looking for just one appliance, not various items that were going on. It's that ability to solve the problem quickly and know what the kind of cause is. So, yeah, that's the brief and the techie part. I'm sure you guys will be happy with that. So what I want to talk about now is the other side, the actual behavioural change front end. So you've got a lot of staff in your business, and as mentioned before, they can actually cause 10 to 15% saving from your consumption. And one of the best things about this kind of high-speed second-by-second monitoring is this cause and effect that your staff will have. So if they've got a data dashboard where they can actually see what they've done, so if they turn on a kettle, they instantaneously see what is happening in the consumption that they've caused. They get this far more appreciation for how they're actually causing or actually affecting the power consumption of your building. So it's an amazing educational tool for them to be able to sit and work out the difference between, for example, I go to a lot of companies and they say, yeah, we're really good, we've been turning off all our LED light bulbs or monitors, which is great, but they've left the air conditioning unit on all night. So that's the equivalent of 1,000 energy saving light bulbs have been going on. So it's that understanding and awareness that they would get from real-time monitoring. So I'll show you a quick video.
Hello and welcome to Good Running. This is our demonstration video to show you exactly how our analysis mode, the eAnalyzer energy monitoring system, works. And if you look in the top right hand corner, you can see our kettle, and when I switch it on, you get instantaneous feedback into exactly how much consumption has been used. This allows you to finally both see and understand exactly how much consumption each of your devices is actually using.
So again, being able to display it in this kind of level of resolution means that people won't be worrying as much about the light switches, but actually focusing on the large appliances and see what their consumption's at. So if you've got one of those water heaters which is boiling every 20 seconds during the course of the day, you know, if you save money on that as opposed to the 3 lights that you've got on your desk, there's a huge benefit. So it's staff awareness and getting your staff involved and educated on what's actually causing the consumption gets the biggest savings. So dashboards, again, I'm a big fan. It's putting it in the format that's best utilised for that actual office environment. You've got extra tools in real time where in this one we've got the University of Bath, we've got each of their student halls, and you've got the ability for them to compete with each other in real time to be able to sit and turn the kettle on and the other items to be able to sit and see what effect it has. I'm a huge advocate of graphs and be able to sit and plot things against, say, your perfect day, so you can actually react to these things in real time. So if you see you're above it, you can do something about it rather than have the data from half an hour previously or the previous day even. You also get things like alarms and warnings. So if you've got a company who are around about its breaker point but going over, you can pre-warn them that actually you're about to have a power cut so that they can do something about it rather than wait till the power cuts happen and then try and work out what caused it, where you've got kind of 15-20 minute downtime where someone's actually resolving the power. And you can be informed by out-of-hour irregular usage, so irregular usage patterns. Got a very good example of a restaurant chain that we were monitoring, where from seeing their data in real time, we could see that about 3 AM in the morning there was a slight rise in their energy consumption pretty much every Saturday. So just happened to mention on our reports, and they could tell the exact second at which point that was happening. Going and checking their CCTV camera, they were able to see that the staff were coming back on the early hours of a Saturday morning enjoying the benefits of what they thought was a free bar. So it's that kind of extra level of information that they just wouldn't have known about and probably wouldn't have even shown up on a half-hourly trend. And then again, it's this kind of knowledge of the appliances which are causing the issue. It's one large appliance which has caused your power trip or is causing your high energy usage, you can tell. So, how fast would I say the recommended levels should be? I think on real-time displays and dashboard, that 10 times per second is that instantaneous feel that you get from using an appliance is perfect for the education, perfect to get your staff involved, to see that what they've just done has had a perfect effect on the energy consumption, so they feel involved and they can help manage and be more aware of what's happening. In terms of data sampling, generally to get all the power issues, the ideal for me is 100,000 times per second, which may sound like a huge amount of data, but with the level of artificial intelligence and stuff which is happening at the moment, you don't need to store that data, you just need to see things that are happening, so transients, power spikes, to be able to have it reported. We save all our data down in second-by-second format, put it up to the cloud. You don't need to go much more than that for that, you just need to be able to catch everything. And again, you don't really want to be dealing with all that level of data. You might be like, well, that's completely overpowered. But with automated reporting these days, you don't need to. Like, the analysis is done by the PT and the energy consultant, and you have something you can just see on a facilities manager level or a financial director level or an energy management level. You've got something called our Power Performance MOT. It does all your voltage optimization analysis, power factor, transient stuff that you're probably not even aware of or think is an issue. But this will automatically do it all for you to be able to work it out, so you don't have to worry about it. We just report what you should be most focused on and where you're going to get the best return on investment for your saving. So other questions I get asked a lot are, does it cost more? Well, again, if you're just storing it at second-by-second level, it's 86,400 data points in a day, which is only a 3 megabyte CSV file, which is what, less than 10 minutes on Facebook? And in terms of big cloud data, that's absolutely nothing. So storing all this data up in the cloud doesn't cost a lot at all, and it's very useful for being able to sit and reanalyze it with kind of automated tools. The unit cost itself, all of the meters that you're using all actually have very high-speed chips in them doing this analysis, which is how they calculate the power accurately. They just have very bad comms in terms of displaying the data to you. So smart meters, for example, I think the spec is about 15 seconds, which they consider very good. But they could go a lot quicker, sampling a lot quicker inside. So if you've got a retro meter or something that can actually display it, you get extra benefit from it. Installation cost again, if you're looking at one of the retrofittable type meters, you, as you probably had, British Gas very well, sent out like the OWL type meters for home display. You can literally just clamp it onto your meter and you get that kind of live data. On the commercial level, it's exactly the same, just to scale up. You get 3 current clamps, 1 for each phase, plug in the meter and you've got live data streaming there and then for being able to analyze this. Okay. So, next thing I want to talk about is non-intrusive load monitoring. So this is basically energy disaggregation. So those keen-eyed people probably noticed when I showed the domestic slides earlier that each of those energy signatures is actually quite different to each other. And the joy of this is when sampling at kind of 100,000 times per second, they all stand out kind of like a sore thumb. And you can tell the difference between your kettle, washing machine, dryer, due to things like the harmonics on the line, the effect they have on power factor, the effect they have on amplitude of your amps. Very technical, but you can actually disaggregate off the back of it. And the brilliant thing about that is now you've got the information, what you can actually do is break down your bill into each of those particular large appliances which are causing it, and now work out how much of that bill each large appliance is actually using. So in a domestic environment, for example, you've got your kettle toaster, and you now know it's cost you, £12, it's 3% of your overall bill. and that's just for monitoring a single point, so you don't need those special plugs in each point. You're just monitoring from the mains, you just sat in your garage, etc. So other consumer benefits of that, so not only do you now know in real time which of your appliances are on at any particular time, but at the end of every year, month, or however you want to do your reporting, you can get a return on investment report on whether you should change your air conditioning unit to a more energy efficient one, because after a 6-month period you'll get a return on investment. Even though it's not necessarily broken, you're just going to save money on your energy consumption. So there's this extra level of information you're able to pick up. You also get things like maintenance reports. So if we're monitoring your fridge over a period of a year, 2 years, you can actually tell that the energy signature is changing. Maybe it's a broken seal, or maybe it's another item. You can now tell you that your fridge is actually going into this kind of maintenance requirement. So you'll get a return on investment if you go and mend your fridge or replace it with another one. You've also got things like hidden load, the appliances which you didn't even know were on. On this high-speed monitoring, we can tell that an appliance is turned on or off that you may not even know about. So your out-of-hours usage, you can actually save money and delve into. The cool thing about it all is all self-learning, all artificial intelligence. You basically plug in a new appliance and you'll be able to sit there and automatically learn it for you. So you don't have to keep going and recalibrating your system. And from an energy company's point of view, they're really keen on it because, great, they've got smart meters, they now have accurate billing. So you're still going to have customers worried about high usage, and so they can now sit and explain to them where this high usage has gone and where and how they can save money. So where is this industry at the moment? We've been playing around with it since 2007, and the US and UK are ahead of the curve on it. You've got in the US, they like to visually plot what, and everyone's kind of focusing on smart meter data, so disaggregating data between 1 and 15 seconds, where the accuracy is, it's not great due to the resolution. So you'll be able to get things like large electric showers and your aircon, but you miss out on the harmonic information to be able to delve down and get kind of, toasters, washing machines, and that kind of level. But you can tell by the fact that British Gas have just purchased Alertme for £47 million. Or in that area, I think. A lot of that was due to the actual analytics capability of Alertme and their analytics of the smart meter data. It's very much where the industry's going, with Google on the Nest front and Gas, all about self-learning, $3 billion investment. It's very much where the industry's heading. So the technology's also started to pick up various awards. We've had finalists in the Energy Awards, Energy Innovation Awards. We've picked up funding from Scottish Power and Scottish and Southern Energy to further delve into this over the last couple of years. And they even had the Department of Energy Change and Climate endorse the technology to say they see the benefits in it. So I'm just going to quickly talk about on a kind of technical level why this extra benefit comes, certainly on the kind of higher commercial, and we've been monitoring the substations for SSE. So power quality, they're interested in things like the harmonics and various other things that can affect your grid. We've got a system called the Genius that basically disaggregates your load on a substation level and can sit and tell you if you've got solar panels on the line, electric vehicles, and various other green technology. So what they've got there is they're interested in this flicker report, so they found an issue on the actual flicker. It was above level 1. And the cool thing is what we're doing whilst monitoring that power quality thing is in parallel breaking down their appliances. So you can see the blue line underneath is every time that individual appliance is turned on, mapped according to the day, and the graphs at the bottom are the effect that that appliance has had. So this is appliance E on phase 2, another appliance J on phase 3, which is a very large appliance, harmonics on the first and third. But what's really cool here is you can map appliance J against the flicker report to actually be able to see that it's appliance J which is causing your flicker. So they don't have to sit and worry about kitting out this entire substation with anti-flicker devices. They can actually just go and find appliance J and actually put the kind of profile on there to be actually save money in terms of installation. So having this level of information on the kind of individual appliances can save you huge amounts of money even in just solving problems. So last but not least, I just want to quickly talk about the future. So I see everything going down this kind of actual smart meters where they're kind of self-learning and able to understand behavioural patterns and changes, learn about what's actually happening, and that turns into a kind of intelligent control systems. So imagine in your home you're now going to know that, well, your shower is on, so at the end of the shower, like the coffee machines always turn on. So when you go downstairs, the coffee machine will have turned on because it would have seen that you've just come out of the shower. You've also got things like a robot hoover that if they see that there's no usage during the course of the day, the robot hoover can turn on. So you've got that kind of added control capability. Safety systems, so one of the key things that technology is moving towards is if you're got an elderly relative, for example, in a house by themselves, it can sit and pick up change in behaviour. So if they've not had a cup of tea or not used a kettle or had a shower, etc., it could give you a little alarm for you to be able to sit and give them a call, check they're okay. You've got the ability to have the option of sharing your data with others to be able to do that. You've also got security things. So if you're away on holiday, you can sit and see if anybody has turned up or if there's any irregular energy usage at your house to the instantaneous second as to what's happening, to be able to activate CCTV or other items or get the neighbours included. And you've also got the fact that even when you're away on holiday, you're not going to be wasting any more power anymore because you'll know exactly what appliances turned on and off while you're away on holiday to make sure you turn them off the next time. Yeah, brilliant. So that's the end. Sorry, it was a bit quick.